integration of sine and cosine squared. So in order to do integrals of the form sine squared and cos squared of x or theta or whatever, we need to look at the double angle formula for cos 2x. So we know that cos 2x equals cos squared x minus sine squared x. And it also equals 2 cos squared x minus 1 and 1 minus 2 sine squared x. And let's go ahead and make cos squared x the subject in one of the equations and sine squared x the subject in one. So in this one here, if we make cos squared x the subject, we'll add 1 to both sides and then divide by 2. So we'll have cos squared x equaling, so let's add 1 first. So we'll have cos 2x plus 1 and then divide by 2. So we get an expression for cos squared x. And doing the same for sine squared x, we can add, so we can get sine squared x equaling 1 minus cos 2x all over 2. And these are the expressions we're going to use to help us integrate cos squared x and sine squared x. So let's just look at a simple example first. Just the integral of cos squared x dx. Now, using the formula we just created, we can have the integral of, we can rewrite cos 2x plus 1 all over 2 as a half, all multiplied by cos 2x plus 1 dx. Take the half outside the integral. So we have the integral of cos 2x plus 1 dx. And we're going to have a half times the integral of cos 2x. We're going to have the integral of cos is sine. So we're going to have sine of 2x, and we just divide by the derivative of the function inside. So derivative of 2x is just 2, plus the integral of 1 gives us x, plus a constant. And we can leave it like that, or we could multiply out the half, and we'd have sine 2x over 4 plus x over 2 plus a constant. Let's have a look at another example. Let's look at the integral of 2 sine squared 3x dx. Now, this time we just don't have sine squared x, we have sine squared 3x. But that's okay, because we know that sine squared x equals a half times 1 minus cos of 2x. And we need to recognize that if we have x here, we have double the angle here. So we can rewrite this as sine squared of 3x as equal to a half outside of 1 minus cos of, this needs to be double our angle, so this needs to be 6x. And let's go ahead and sub that in. So we're going to have the integral of 2 times sine squared of 3x. We know that equals a half outside of 1 minus cos 6x dx. The 2 and the half simplify to 1, so we just have the integral of 1 minus cos 6x dx. The integral of 1 with respect to x is x, and the integral of cos, of negative cos, is going to be negative sine. So we're going to have negative sine of 6x, and then we just divide by the derivative of the function inside, and derivative of 6x is just 6, plus our constant, and that's going to be our final answer. Let's look at another example. Going to have the integral from 0 to pi of cos squared x over 2 dx. So again, we just don't have plain x here, so we need to do a bit of manipulation. So we know that cos squared x equals a half outside of 1 plus cos 2x, where this angle is double this angle. So if we have cos squared of x over 2, that's going to be a half outside of 1 plus cos of the angle that's double x over 2 is just x. So that's what we're going to substitute in. So we're going to have the integral from 0 to pi of cos squared of x over 2, which we know is a half outside of 1 plus cos x dx. We can take the half outside the integral and then start integrating. So the integral of 1 is just x. The integral of cos x is sine x. And we have from 0 to pi, so we have a definite integral this time. Then we're going to start subbing in. So we're going to have a half outside of sub in pi for x. So we're going to have pi plus sine pi minus, now it's sub in 0, 0 plus sine 0. So we're going to get a half all outside of pi plus sine pi is just 0 minus 0, then minus sine 0, which is also 0. So we just end up with pi over 2 as our final answer.